Hello, everyone. My name is Lexi Kumar, and I'm a rising junior in high school who likes to hang out with friends and family, go to the gym, and has an aspiring goal for college that I'm working towards every single day. Now, in these series, we'll be going over the basics of what a quantum computer is, how we can code a simulation on it through computer science. Now, this may sound like a lot, but please do not worry, as no experience is needed in knowing what a quantum computer is and how to program a simulation for it through computer science. As in this series, we will be going over it step by step. And it's all about having fun and learning about this mind-blowing subject really quickly. All right, so let's talk about quantum computers. So before we dive deep into quantum computers, I'll just cover what we're going to be going over in this video. So we're going to be going over what a quantum computer is, the various impacts a quantum computer can have on our society, the difference between a quantum computer and a classical computer, and the overview of the Python simulation of a quantum computer that we will start coding later on. So, what is a quantum computer? Well, it's a type of computer which uses quantum mechanics so that it can perform various types of computations at a much faster pace than a regular computer. Now, what I just said might have sounded kind of advanced. Well, what I'm really trying to say is that a quantum computer has the ability to solve top notch and difficult calculations way more faster than a regular computer. Now, as I just mentioned, it really has the capability to solve the world's problems, right? And it literally is the future. Now, this new generation of technology includes a new type of computer that is 158 million times faster than the most modern supercomputer that we have in the world today. So I just said supercomputer, but just imagine how advanced it is compared to a regular computer. All right, so what are the impacts a quantum computer can have on society? Well, what is taking centuries for humans to find to solve a really complex calculation will only take minutes for a quantum computer to find. Quantum computers themselves can solve calculations that are too complex for humans and the most advanced supercomputers. This can be backed by Google, who proclaimed that a quantum computer can carry out a really substantial calculation in about 200 seconds that would take a classical supercomputer about 10,000 years. So we really do want to pay attention to these time differences. Now, how is this possible, right? Well, the computer and its algorithms would allow for the storage and processing of data in ways that we can't even imagine today, right? And these types of calculations would involve solving the cure for cancer, you know, how to solve for carbon emissions and lowering carbon emissions, right? If we ever had another pandemic like COVID-19 again, which I hope we don't, um, this quantum computer could potentially find the vaccine for it in seconds, right? And it's truly remarkable to see what a quantum computer can do and how it can solve for world-related problems like finding the cure for cancer in just um, in just seconds, right? And this influence of quantum computers can possibly even change the trajectory for the industrial revolution. It will truly leave a huge mark in the world's timeline. So truly, quantum computers can have a huge and positive impact on our society. So we just went over the positive impact that a quantum computer have on our society. But now we're just going to be going over the key differences between what a quantum computer and a classical computer are, right? So, as mentioned, quantum computers are way more advanced and faster than classical computers in terms of computing these really intricate and complex level algorithms, which are a set of instructions. Now, how is this possible, right? Well, does anybody remember what binary code is? Maybe you might be familiar with 010101, right? Well, a binary is a system used in digital computers where numbers and values inputted by the user are expressed as 0 or 1. Now, for computers specifically, 1 is either true or on, and 0 is either false or off. And these are the two possible states, 0 and 1, in which a binary number system can be represented in. So essentially, what I'm trying to say is that computers operate in binary, meaning that they store data and perform calculations using only zeros and ones, which means that all computers' calculations and functions boil down to binary. Well, we just said that a classical computer can either only be in a state of 0 or in a state of 1 to calculate these computations. But a quantum computer can be in both states of 0 and 1 at the same time. And as a result, it has its own binary system that is way, way, way more advanced. And this binary system implements a quantum algorithm in the computer, which can compute all possible inputs in the same time. Meaning that if we were to find the cure for cancer, right, there would be a numerous to like infinite amount of solutions for that cure for cancer. And then when we put those infinite amount of solutions as an input in the quantum algorithm, what it would do is that it would scan through all of the solutions all at the same time, meaning that it would instantly find that one outlier, which would be the one cure for cancer. Now, this would be done, as I just said, in a matter of 200 to 300 seconds, right? It's not even, we just know that it's going to be pretty fast, right? It doesn't need to be that specific. But a classical computer can only compute one input at a time. Now, what does this mean? Well, let's go back to our example of the numerous amount of solutions for cancer, finding cancer, right? If we input those infinite to numerous amount of solutions in a classical computer's algorithm, it's gonna find and go through all the solutions one by one. Now, I hope everyone knows that what that means. That means that it's going to take possibly forever to go through an infinite amount of solutions to find a single outlier in a classical computer, which is really where you could see the main key difference over what a quantum computer is and its ability between the ability of a classical computer. And just if nobody's realized, the classical computer are the regular laptops and the computers that we use in our modern daily lives. So, good job so far, everyone. Give yourself a pat on the back as we just understood the ability of what a quantum computer is, how mind blowing it is, and the certain, the certain impacts, positive impacts it can make on our society. So, now, as we go through the tutorial and the other upcoming videos, we will all start understanding the puzzle, right? Piece by piece of the true content behind what a quantum computer is, the basic logistics. And we're also going to be understanding the basic scope of the code we're going to be needing to create the simulation of a quantum computer in Python. And again, Python computer programming experience is not needed, as we will be going over the basic logistics of Python to create the simulation. So please do not worry about that at all. All right. In the next video, we will just be talking about what an algorithm is. So till later then, folks. I'll see you in the next video. Bye-bye.